So this 6-part program is reimagining the definition of healthy materials to recognize all impact categories, including circularity, carbon, water, and equity. Each episode invites speakers from design, policy/academia, and environmental justice to share their perspective and offer insights into how we create a better built environment. This series is a collaborative effort between the American Institute of Architects Committee on the Environment in San Francisco, the Carbon Leadership Forum SF and Los Angeles chapters, and the US Green Building Council in LA. In the previous episode, we discussed building systems with Bill Walsh of the Healthy Building Network, Ruby Yepes from Southern California Edison, and Kathleen Hetrick from Borough Happel. Today, we will hear from 3 speakers, followed by a panel discussion and Q&A. Please add your questions to the chat box, and if you're interested in learning more or creating working groups, please add your contact info to the Google Sheet attached. We are joined today by Veena Singla, Henry Valles, and David Benjamin. I'll introduce each of these wonderful speakers before their presentation. And first off is Veena. Veena is a senior scientist at NRDC. She aims to create healthier indoor environments by limiting the use of toxic chemicals in the built environment and everyday products. Her research focuses on understanding how toxic chemicals threaten the health of vulnerable populations, including pregnant women, children, and workers, through an interdisciplinary approach to incorporating environmental health, exposure science, public health, and policy expertise. Veena, you want to take us away?
Thank you so much, Brian. And let me just get my presentation up here. There we go. Well, thank you, Brian, for that kind introduction. And also thank you to you and Kathleen and the other organizers for coordinating this important series. I'm really delighted to be here. I was just looking through the participant list briefly, seeing all the great names and not recognizing a lot of them. So I'm really excited to be speaking with you all today. So here's the plan for today. I used to call this slide a roadmap, but when I was making this presentation, I kind of realized I'm so much happier on a trail than driving. So I changed it to trail map. So anyway, I'll tell you a little bit about NRDC, the Natural Resources Defense Council, and our work, and then talk a little bit about some research on the spray foam building insulation life cycle that I'm currently doing that I feel like illustrates some of the central problems with today's materials really well. And then I'll finish up by talking about some new policy frameworks that are emerging to really support the materials of tomorrow that we need. So NRDC is an international nonprofit that employs scientists, lawyers, and policy experts to advocate for evidence-based policies to protect human health and the environment. We have a staff of about 700 and offices across the US and San Francisco, where I'm based, as well as Los Angeles, Chicago, Washington, DC, New York, as well as internationally in Beijing, China. We work on a range of critical environmental issues, including climate change, energy, nature, and food. I'm a scientist who works at the science policy intersection on environmental health issues. So environmental health is all about how the environment impacts people's health. And I do research analysis and science communication to bring the most current scientific principles and data to inform better policies, especially focused on chemicals, healthier buildings, and healthier building materials. So one of my current research projects is focused on spray foam, and this insulation material use has increased in buildings because of its performance for energy efficiency. So it has really good insulation values as shown in this R value chart here, and it can also act as an air barrier material. But what I really wanted to understand was more about its broader impacts across the life cycle. So to do that, in collaboration with the Healthy Building Network, I think Brian mentioned you already heard from Bill Walsh earlier in this series, working together with them to really understand the life cycle chemical impacts in the US of a key spray foam ingredient. And thinking about that potential impact at the kind of different life cycle stages shown here, from chemical manufacture through use all the way to disposal, and looking at those impacts through the lens of concepts that you've discussed in the series that are in that materials primer, kind of considering materials more holistically, thinking about material health, circularity, waste, and social equity. So here's a quick preview of what we've found so far. So the key ingredient in spray polyurethane foam is called MDI, and it's a type of isocyanate chemical that is itself toxic. It's a respiratory sensitizer chemical. And we found that the chemicals used to manufacture MDI come from fossil fuels, and that these manufacturing and process chemicals are also hazardous. They can cause asthma, cancer, or immediate injury on contact. And the picture here shows one of the facilities that manufactures MDI in Baytown, Texas. So we found that in the US, overall, there's 3 facilities that manufacture MDI. They're all located on the Gulf Coast of Texas and Louisiana, shown in the purple icons on the map there. And together, these facilities release on average 560,000 pounds of hazardous chemicals into the air and water of these communities every year. The facilities have a history of EPA non-compliance, and multiple accidents have been reported that injured workers or resulted in releases so toxic that surrounding communities were ordered to shelter in place. And these communities are disproportionately people of color. So in Louisiana, the percent Black population in the 3-mile radius around that facility is 2 to 3 times higher than the national average. And around the Texas facilities, the Latinx population, again, is about 2 to 3 times higher than the national average. And then looking at that end of life cycle stage, what we found is that spray foam is largely landfilled, and in that process can release microplastics and hazardous chemicals. And we didn't identify any reuse, recovery, or recycling pathways for spray foam. And this seems to be partly because it's challenging when the material is foamed in place and adheres to the surrounding building materials. So in summary, our case study found that spray foam performed pretty poorly in these important areas. It contains toxic components. There's no pathways identified for recovery, reuse, or recycling.
There, you can come out.
We're seeing large amounts of hazardous waste generated in the manufacturing process. And this is disproportionately impacting Black and Latinx communities in proximity to these facilities. So this really illustrates the negative, broader impacts that can happen when you're only focused on one aspect of a problem, like building energy use. So where do we go from here? And as someone who thinks a lot about policy and how policy can really help to support and drive the changes that we want to see, I wanted to share about some exciting new frameworks that are really taking different approaches to these intersecting issues of buildings, climate, chemicals, equity, these issues that kind of sit at the center of like that spray foam case study example. So these have all come out in the last year or two. It's really the kind of the latest thinking. And I'll talk briefly about each of them. So we have the health and well-being framework from the World Green Building Council, the chemicals strategy for sustainability from the European Union, and the equitable and just national climate platform. So the World Green Building Council released last year these principles for a healthy, sustainable built environment. And if you're not familiar with the World Green Building Council, it's an international organization that's part of the UN Global Compact, and its members are all green building councils from around the world. So for example, the US Green Building Council is a member of the World Green Building Council. And their mission is to advance the UN Sustainable Development Goals and positively advance climate action, health and well-being, use of resources, and a circular economy. So this framework has 6 principles for a healthy and sustainable built environment. And some of the examples from the different sectors they cover, in the protect health category, they're thinking about air and water quality, mental health, and community health. In the take climate action bucket, they're thinking broadly about adaptation, efficiency, and material health. And it's also important to note that they're really thinking about all these principles across the life cycle of the built environment, not just focused on the building occupants. And there's also the one piece of the pie there around creating social value. So they're really thinking about human rights and worker health as well. So that's kind of that frameworks from the buildings focus, and from the chemical focus, the European Union chemical strategy lays out this new vision for chemical policy, which I would say kind of flips the current model on its head, because currently when we think about chemical policy, we're really thinking about the bottom 2 pieces of that triangle, the orange and red pieces, where we're trying to really minimize and control hazardous and toxic chemicals or remediate legacy problems. And what this strategy does is really say, we want to start with safe and sustainable chemicals. That's our foundation, and that the other 2 strategies are the less desirable strategies. So it's really thinking about how do we have safe and sustainable by design chemicals, and also advance those UN Sustainable Development Goals more broadly. And finally, from the climate and equity focus, the Equitable and Just National Climate Platform, it's a collaborative effort between national environmental organizations like NRDC, of which I'm a part, and environmental justice groups and advocates. And it lays out this bold climate policy agenda that advances these intertwined goals of economic, racial, climate, and environmental justice. So there's many related pieces of that agenda that you see here in these boxes. And I wanted to point out one really important theme that really runs through and connects a lot of these areas. And that's these buildings, systems, and economies that work for people and all people. So really thinking about local and regional supply chains and inclusive access to high quality, safe, and family sustaining jobs. So each of these policy frameworks is kind of coming from a different perspective, right? Focused on buildings, focused on chemicals, focused on climate equity, but there's some really important common themes between them, which I think are all major departures from how policies are constructed today. So I'd say first, today's policies tend to be pretty reductionist and address only a narrow aspect of an issue like building energy use. Whereas these policies are much more holistic and explicitly recognize the need to address interconnected systems and transform systems for change. Today's policies are focused on minimizing harm, so trying to do less bad, such like let's reduce risks from hazardous chemicals, whereas these new policies are really trying to create positive change. So for example, how do you create social value by supporting community wealth building? Today's policies tend to perpetuate historical marginalization and disproportionate harms of current power structures, while tomorrow's policies are really aiming to bring marginalized communities squarely to the center of decisions that affect them and to be partners in solutions. And then finally, policies today tend to kind of be separated in silos by different sectors. So, these deal with chemicals, these deal with buildings, these deal with climate, whereas each one of the policy frameworks I mentioned really sees common cause across these different sectors, and again recognizes that the interconnected nature of our systems that are creating the problems. So all of the policy frameworks I reviewed all mention advancing the UN Sustainable Development Goals as kind of foundational commonality. So I think we have a real opportunity to make a difference to communities that are most impacted by harmful building materials. And I really believe that these changes are possible when we come together to work for them. So thank you so much.
Thank you, Veena. That was fantastic. It was really great to hear about spray foam, which is this material that we've been using, endlessly for so long, and then to hear conversely about a new practice, a new mindset around policy. Next up is Henry Valles. Henry is the founder of the Hemp Building Ventures, a consulting and development company bringing hemp-based building materials to mainstream real estate and construction industries. He's also a founding board member of the U.S. Hemp Building Association, the Texas Hemp Coalition, and a licensed NAR Green Certified Realtor with Realty Austin. Inspired to bring more sustainable and non-toxic solutions to the real estate and building industries, Henry continues to educate his community and champion the use of hemp-based building materials through his real estate and hemp building consulting practices. Henry, go ahead and take the screen.
Thank you so much, Brian, and thank you for inviting me to this. That was an amazing presentation and excited to contribute. So let me get my screen shared here. Alrighty, so I'm gonna be talking about hemp and some different applications and how hemp can be used for the built environment. So when people hear about hemp-based building materials, they usually hear about hempcrete or hemp lime, like other people refer to it as. And what hempcrete is the woody core of the hemp stalk mixed with a natural lime binder or natural cement and water, and formulates this lightweight concrete-ish insulation replacement. So what's so great about industrial hemp, it's that it's one of the fastest growing plants out there. And you take the woody core of the hemp stalk and you remove the fibers, and what you're left with is the woody core, which is what you use for your infill mix. And there's different types of binders that you can use. Hydraulic lime, hydrated lime with a pozzolan, pre-blended binders, and natural cements. And some of the benefits of hempcrete or hemp lime is that it's carbon sequestering. It has excellent moisture and thermal capabilities, fire, mold, and rot resistance. There was an ASTM fire test done, a fire spread test done that came back with a 0 score, which was one of the first done here in the United States. Also helps improve health due to improving the air quality and is 0 VOCs. And then people are starting to look into more of its RF and EMF reduction capabilities as well. There's 4 main ways to install hempcrete. One is the cast in place in the upper left-hand corner, kind of like a rammed earth. You use the form boards to build up the insulation wall where you surround your studs. The second to the right of that is hempcrete blocks already pre-manufactured. All you need to do is mortar them together and you're good to go. The bottom left is pre-panelized wall systems to help expedite the process and control the curing of the hempcrete. And then on the bottom right is the sprayed applied hempcrete. So this is much faster, along with the blocks, that helps cut down the installation time and the labor costs, which cast in place on the upper left-hand corner could get a little bit more costly with. So there are other hemp-based building materials. Hemp fiber insulation, hemp wool is one. It's an easy plug-and-play material instead of hempcrete. A lot of the hempcrete installation takes some training and a little bit more advanced contractor knowledge. There's hemp wood on the bottom left-hand corner, an amazing material replacing wood floors for more sustainable options for flooring like bamboo. Hemp shield, which is a non-toxic wood sealant based from hemp oil. And then Canagrove is a company that has hemp-based wood fiber alternatives for cabinetry and other types of wood forms. Also, hemp-based plastics. There's a company, Hemp Plastic Company, that's doing incredible job replacing a lot of petroleum-based plastics with hemp natural plastics. So lots of plastics used in the construction and building industry as well. So if we can start to implement more of these, more non-toxic, biodegradable would be great options, especially for the workers on site where inevitably ends up in our soil. So some of the current limitations that we have in the hemp building industry, and especially in the industrial hemp industry, is the availability of local materials. A lot of these materials are sourced from Canada, Europe, and a lot of the issues is we don't have a lot of farmers growing for the industrial hemp crop. Mostly it's grown for CBD. And also we don't have a lot of the processing capabilities yet. So there are companies, IND Hemp out of Montana. There's a facility coming up here in Texas that are really trying to encourage and focus on the industrial side of hemp and getting those processed materials, especially for the construction and building industry, to help support this demand. When it comes to hempcrete as well, quality control, making sure that the labor is skilled and knowledgeable. There are some different intricacies when you're using hempcrete to take into account. Educating experienced architects, engineers, and contractors, starting to get hempcrete and hemp-based building materials acknowledged in the local building codes as well. And if you're looking to use hempcrete also, upfront construction costs can be up to 10 to 30% higher than traditional stick frame construction due to the current above limitations. But once we can start to find faster ways to implement the insulation and have more efficient ways of educating our contractors, that cost can be reduced. And also with the localization of processing and industrial hemp growth here in the United States. And then also understanding other material compatibility when it comes to hempcrete. When you're using hemp fiber insulation like hemp wool, that material compatibility isn't as important. Or hempcrete, you want to make sure that you do have vapor permeability. So I'm sure as many of you know, especially being a part of this group, the most important thing that we're really trying to reduce here is our carbon footprint. So a lot of the industries and most people I'm sure you talk about out there are really just focused on operational energy, where we're really looking to focus on the embodied energy of the materials that we're using. So one of the great things, I apologize. One of the great things that hemp is able to bring is a localized material that is very highly carbon sequestering. Also, when it comes to the line binders that I was speaking of previously, you can be able to localize that, looking for localized pozzolans and localized hydrated lime to really localize the supply chain and regionalize that. So it's very important, and the U.S. Hemp building industry really is focusing on reducing the embodied carbon as much as we can by trying to support the different regions when it comes to localizing industrial hemp farming and helping get processing facilities in those different regions as well. So the global CO2 emissions accounts for almost 40% with the building operations and building materials and construction. So we really feel that the industrial hemp building industry can help reduce that. And one of my favorite books, The New Carbon Architecture by Bruce King, he actually did a carbon sequestering insulation study with hempcrete and found that the CO2 sequestered from a 4x8 foot wall at a R28 insulation value was the most carbon sequestering just above straw bale. So if we can really educate our building industries to start to use these types of materials and alternatives, one, we're making a healthier built environment, but also helping with the solution of reducing our carbon footprint. And a lot of people ask, especially with hempcrete, what is the carbon sequestering nature and the percentage that comes out of it? But so most of the carbon sequestered during the process is through the cultivation of the industrial hemp. The rest of that 10% or so is the calcification when the hemp is mixed with the natural cement or hydrated lime, and the wall insulation system begins to harden. So that's the percentage breakdown of the CO2 sequestration. So I'd like to encourage people. Before, I used to always be pulling, examples of hempcrete structures in Europe or in Australia. But as I'll show you here in a little bit, there's actually a lot of great projects coming up. But up here in the top left-hand corner is an affordable housing project in the UK called the Triangle Housing Project in Swindon. One of the first affordable housing projects built with hempcrete. To the right is a beautiful condominium project that they did in Italy. And then they started to use, they used hempcrete for the construction of a Mark and Spencer's department store that they found almost a 40% reduction in their operational energy use. So getting commercial projects has already happened in Europe. Unfortunately, we haven't gotten there yet in the States. I'm hoping here in the near future that'll begin to be the case. But the US is starting to compile quite a bit of projects, which is great for local building code education, getting builders and contractors more comfortable and excited to use these materials. Up in the top left-hand corner is the Highland Hemp House out in Bellingham, Washington. That was the hempcrete was installed by Hempitecture, as well as one that they did here down in Leander, Texas, which is right outside of Austin. This one was more of a custom home built that they used a Minka frame from Japan, a very unique project. I wouldn't say it's the most the nicest carbon footprint on that project, but very unique and beautiful architecture. One of the first hempcrete homes that was built in the US was in Asheville, North Carolina. That was actually built for the mayor. Has been seen and really set the tone for the industry. The first permitted hempcrete home out in Denver, Colorado. The Wonder Workshop that was built by Left Hand Hemp. And then here in the middle, just to show what's within your walls, because you're usually plastering them, and to show the beautiful insulation, a lot of people do a truth window. But like I mentioned before, you know, understanding and getting be able to increase the speed and the efficiency of installing hempcrete. There have been also a couple affordable housing projects. Here to the left by Microbes, the Healthy Materials Lab, and the Parsons New School and Dawn Services did an affordable housing project that the Pennsylvania Department of Agriculture had a grant for over $200,000 that Dawn Services won and partnered with the USHBA, Microbes and Healthy Materials Lab, that they were able to restore an affordable housing unit using sprayed applied hempcrete. So getting that into the affordable housing community, I think, is an amazing, equitable way of doing things. Down here to the bottom right, it's an amazing community called Community First Village, where they have multiple tiny homes and RVs for the chronically homeless and disabled. This was the project that I worked on and fundraised for to just show an alternative building material, more healthy and sustainable. That's in Austin, Texas. And what's encouraging, there's more and more companies out there learning and implementing these types of materials. Hemp Stone is a company out of Western Massachusetts. They did a beautiful cast in place here to the bottom right in Western Mass using cast in place hempcrete. And here to the left is a sprayed applied hempcrete home out in Cape Cod. So more and more companies and more code, building code enforcers are beginning to learn about these materials. Coexist, a company out of Pennsylvania, did its kind of do-it-yourself hempcrete lime tiny home efficiency. And I think they did about 30, 40 initial sales that they're about to ship out. So that was a huge success. A lot of great feedback and desirability for that. Also, when we're getting to the scalability of these hemp-based materials, we really need the infrastructure and the manufacturing to bring it localized. So Hempitecture, like I've mentioned before, just did a WE funder and raised over $3 million to build an industrial hemp fiber insulation plant in Idaho. So instead of having to ship from Canada and other sources, we're able to localize that, and they'll be sourcing industrial hemp from Montana. So this is a pure example of really beginning to regionalize and localize our supply chain to reduce our carbon footprint. Like I mentioned to you before, Hemp Wood, which is a Fibonacci based out of Kentucky, back in 2019, they raised about $6 million to bring a localized industrial hemp wood flooring company. So it's starting to grow as the industrial side of the hemp industry gets more desirable, and the demand is growing out there as well. And so also it's important to really have the research behind these types of hemp-based building materials. And many universities has, like Murray State, UC Riverside, University of Kentucky. Kentucky really, led the way in the initial onset of the industrial hemp. industry, especially back when the Farm Bill was released in 2014 and the new one came out in 2018. The Healthy Materials Lab at Parsons has done amazing work, and they have an incredible research project that they did for more information. And then also here in Austin, Texas, the UT's own materials lab at the School of Architecture has done some studies on industrial hemp-based building materials as well. So, and then also education and connecting with more people in the industry to understand, how the material is being used, what are some of the positives and negatives and some of the roadblocks that we're experiencing. The U.S. Hemp Building Association is holding a virtual conference, the Hemp Build for 2021. Also, there is a live event here in Austin at the beautiful Austin Public Library downtown, state-of-the-art, LEED certified, very sustainable, gorgeous, architecturally designed library at the end of October for the Hemp Building Summit. And then if you're looking for any other resources to know more about the intricacies, how to build with hempcrete and industrial hemp-based building materials, here are some great resources for you to go research as well, like the one I mentioned, the Hemp Lime by the Parsons Healthy Materials Lab. So thank you, everybody.
Thank you, Henry. That was a fantastic presentation and a great deep dive into hemp. As a reminder, we will have this recording on our website, so and we will release all of the resources that all the speakers are providing, so don't worry if you weren't able to catch that just then. Next up, we have David Benjamin. David is the founding principal of The Living and an associate professor at Columbia GSAPP. His work combines research and practice with a focus on an expanded and actionable framework of environmental sustainability. His recent projects include the Hi-Fi branching tower for MoMA PS1 made of a new type of biodegradable brick. All right, Benjamin, David, go ahead and take it.
Great, thank you so much. It's very exciting to be here at this event. Let's see if I can get my presentation going. So I did want to say, as others have said before, thank you for organizing this important event. And thank you also for inviting me to be here and participate, in this great forum. So first, before I describe a couple of ideas and projects, I would first like to acknowledge the incredible team that I work with. All of our work in my studio is collaborative, and these people on the screen here, individually and collectively, literally bring it to life. So we are a small firm. We focus on research and practice. Recently, we've been working on some examples of healthy materials in some more traditionally commissioned buildings. Such as the Embodied Computation Lab that we designed for Princeton University, shown here. This is a project that we designed as an open source building, specifically designed to be changed over time by multiple authors. And it involved the use of a repurposed material. In other words, we took scaffolding boards from New York City construction that would otherwise end up in a landfill. These scaffolding boards are these kind of 2-inch by 10-inch by 8 or 10 feet long planks that are used at every construction site in the city, and we kind of incorporated them as a material into our building facade. And we took these boards, a lot of different variation in them, a lot of kind of cracks and warping, and we processed them in a kind of custom way using computation and fabrication to create a new building facade out of old materials, basically. And here you can see it at a couple of different scales. For this lab, for this building that we kind of consider to be a living lab, growing and changing over time. So that's one example of a possible definition of healthy materials using repurposed materials. But for the sake of our discussion on tomorrow's materials, I thought I would show two experiments in materials that may be healthy in new ways and kind of different ways. And the first is our work with mycelium materials. So this is a project that began with our thinking about the Earth's normal natural carbon cycle, this endless loop of growth and decay and regrowth, and with thinking that's now sometimes called circular economy. Some of it's, I'm sure, been some of it we've talked about already today, and it's been covered in past events, the series. But our thinking here was maybe we could take waste as a raw material instead of high value raw materials, spend a very small amount of energy converting the raw materials into building blocks, make a useful structure, and at the end of the useful life of that structure, take all of that stuff, all that physical matter of the building, and return it back to the carbon cycle instead of having it sit in a landfill for hundreds or thousands of years. And our way of doing this was to think about using a living organism called mycelium. Mycelium is the branching root-like structure of mushrooms. You can see it here under the microscope video. And one of the really interesting things about mycelium is you can combine it with agricultural waste, such as hemp, for example. We just heard great things about hemp, or say corn stover, not the high value part of growing agriculture like corn kernels, but corn stover, chopped up corn stalks. Put those two things together, mycelium and agricultural waste, and in about 5 days, it grows into a solid object. This is a really interesting, healthy material that's being used in a number of different applications for packaging and industrial design. And our idea was to use it to experiment with a new kind of load-bearing architectural brick. So here was the brick that we came up with. We did a huge amount of testing, single bricks under compression and small assemblies of bricks. And we had to do this testing because we wanted to create a relatively large-scale outdoor structure. Here you see the structure that we constructed in about 3 weeks in the courtyard of the Museum of Modern Art's MoMA PS1. So this is part of the Young Architects program, where for 15 years an experimental structure was built every summer. And here we kind of combined into our mix not only thinking about healthy materials, but also thinking about labor and creativity and construction. We had Columbia University architecture students who knew a lot about form and architecture, combined with New York City brick masons who knew a lot about stacking objects to creatively solve problems on site. So here was our finished structure, shown in the context of the glass and steel buildings of Manhattan in the background, and the traditional clay brick building of MoMA PS1 a little bit closer. And we built this structure. It actually has some hempcrete blocks at the bottom, but most of these bricks, 10,000 bricks, were mycelium bricks. So this was a kind of medium scale test, about 10,000 bricks, so more than just a few objects, to see if we could do this reliably, and about 40 feet tall to see if we could make something more than one story out of it. And we were interested in the capacity of a structure like this to be interesting architecture. So could it make interesting light and shadow and texture? What would be the foreground and background effects? How could it frame the natural environment? But the ultimate test of any project at MoMA PS1 in the summer is its ability to host a good party. So here was the first Saturday of the summer. This is back in 2014, when 5,000 people came to the courtyard to hear music, and they were going inside our structure, scratching it, climbing it, and finally, when darkness fell, we breathed a sigh of relief because we knew it was going to work and be safe. So it made us kind of nervous. It was thrilling, but also terrifying to have people walking inside this experimental structure. But it was also entirely fitting for us to test this new idea about materials out in culture, in society, in public, in a way, rather than just on a lab bench or in the kind of fenced off corner of a construction site. And there was this kind of engagement with the public through things like social media, these kind of short form reactions of people who didn't know much about the architectural story, but were just kind of coming to a museum and encountering it. And then at the end of the summer, and probably most essentially, what we did was take apart the structure, crumble up the bricks into smaller pieces, combine them with some other living organisms, in this case, bacteria and worms, in a composting site. And in just about 60 days, all of that physical stuff of the building, all of the matter, returned to high quality soil. And we were able to use that to give to New York City tree planting, but also to give to New York City community gardens, essentially proving that this is a material that was healthy enough to eat, in its next incarnation. One of the bigger ideas that we took away from this project, in addition to thinking about a single example of a healthy material, was something to think about more generally, that maybe as architects and designers and engineers, we could think about designing to disappear as much as we normally think about designing to appear. In a way, I wanted to describe how this project kind of is an open-ended type of research project. It wasn't designed to be conclusive or finished. It was designed to generate new questions and new possibilities. And in this case, we had a number of ideas about mycelium materials that we weren't able to explore for the museum installation at MoMA PS1, and we found an opportunity to explore some of them a couple of years later. So I'll just describe that really briefly. One of the things we are most interested in is using this kind of living material, a material that could be potentially alive in its built form. So for PS1, we used a material that was alive during its formation, but then the bricks were dried out. They became dead, inert, and predictable, like all typical building materials. But we were interested in the possibility that if we didn't dry out the material, if it didn't become dead and inert, what might we be able to do? Might this material have some of the properties of living organisms, like self-healing and self-attaching and growing? And this is a project or an idea that we explored in a project for the Pompidou Center relatively recently. So we started out by experimenting with growing new units of material and placing them next to each other when they were still growing and alive. And we quickly saw that we were able to achieve what we're now calling biowelding. So the units actually fuse together, and by having a living material, you can have basically brick and mortar in the same object. And here's an example of something we created with that process, which was, a kind of architecture scale experiment or installation for an exhibit in the Pompidou Center in Paris. And here we've created these bucket-sized units and arranged them through a few different ways, including a formwork and a material jamming effect, but basically then used the living capacity of the material to have it weld together or fuse together into a kind of solid structure. And, suggesting, maybe new possibilities in healthy materials if we work with materials that could potentially literally be alive. And so the last thing I want to describe is a second and different experiment with what we could call tomorrow's materials. In some work we did with what's sometimes called the urban microbiome. So just as the microbiome in our human gut contributes to our individual health, the microbiome in our cities may contribute to our public health. And this is a project we did with two good friends and colleagues, Kevin Slavin and Elizabeth Henoff, and it builds off some amazing work that they did together at the intersection of biology and cities. So this project was originally an installation at the Storefront for Art and Architecture in New York City, and we set out to explore a couple of different kind of concepts about materials. The first is maps, and the next is models, and I'll explain that in a second. So for maps, we wanted to measure the microbiome at a gallery in Soho in New York City and compare it to the microbiome of places like the Brooklyn Navy Yard. And for models, we're exploring design scenarios for architecture that actually promotes microbial life. And we're thinking about whether something like probiotic architecture might be able to improve public health. So how did that work? To do this, first we developed what we call a bioreceptive material to catch and host microbes. And the material we started with is wood. So wood is, of course, well suited for hosting microbial life based on its molecular composition and some of its micro and macro shapes. And at the Storefront gallery space, the panels of the facade of the building were transformed with wood tiles cut from standard lumber and then deliberately eroded through sandblasting at various depths to create diverse microclimates. So each microclimate has distinct grains and knots from the wood that create different pockets of shade and moisture for microbes. And this allows us to see that even the most common and humble building material, a cheap 4-inch by 4-inch post of Douglas fir, potentially has a material story to be uncovered that may offer a range of visible and invisible effects. Again, we did a lot of testing, a lot of our kind of design build, fabricating this stuff ourselves. And so here you get a sense of what it was like on the facade of this gallery. So in terms of like the physical presence of materials, with this building envelope of a bioreceptive wood, we could think of architecture as becoming a sensor for the urban microbiome. And then for the second part of the project, in terms of materials that are actually living, we set up a lab inside the gallery in order to sequence DNA of the microbes on site. So bear with me here, it gets a little technical, but here are some of the basic steps. First, we swabbed the sandblasted wood tiles from each location to collect any surface microbes. Then we placed this swab in a liquid solution to break down the cell walls. We separated the DNA from other substances and added marker beads at the end of the DNA to produce a pure DNA solution. So all of this was so that we could load the DNA solution from swabbing the architecture, basically the healthy material, into this thing called a flow cell to be processed by a portable DNA sequencer. And here you see it at work. The sequencer converts this electrical charge into the sequence data, which is basically the genetic code, the A, T, C, and G that we know of as creating DNA and code. And so finally, after we sequence the DNA from each location, we designed the system to automatically draw the output as an early and rough map to an uncharted territory. So the map is a kind of coarse resolution, but it's already allowed us to see some interesting things. For example, in the Brooklyn Navy Yard, we're seeing microbial DNA that performs the function of breaking down heavy metals, which indicates that the Navy Yard has specific pollutants not found in Soho. So based on sequencing the DNA from architectural materials in one place and architectural materials in another place, you can find out some of the things that are going on in those environments. The architectural material becomes a kind of a sensor. So overall, we're using this kind of installation as an active living experiment. We're exploring a new kind of material or an architectural envelope and seeing some of the important matter and organisms that help keep us alive. We're looking at materials and their layers of kind of living things, reframing buildings as stewards, not only for humans, but for the urban microbiome. And the initial evidence indicates that our collective future, the future of all humans plus all non-human animals and all microbes, is probably a lot more collective than any of us can see or imagine. And finally, just to show how this kind of project, again, is a kind of ongoing experiment that kind of keeps going. We have been thinking about how, not only something like sandblasted wood, but probably all materials, even, all organic materials, but even non-organic materials are literally alive, and they always have been. And this is because they're teeming with these invisible layers of microbes. So in a project that is currently on display at the Venice Biennale, we wanted to experiment with what this could mean for some of the buildings and cities of the future. Here we're exploring a different bioreceptive material, and thinking of it as a kind of prototype for a multi-species building. So I'd like to conclude by offering a kind of story or a vision about, in a way, about tomorrow's materials and the future of living buildings that we hope would be relevant and capture the imagination of both, some architects and designers, but also the general public. So I'll just kind of read this story, and that will be at the end of the presentation. So microbes are everywhere, invisible to the human eye. They live in the air, within the walls, and on even the cleanest of surfaces. We have always lived together with microbes, and the vast majority of microbes contribute to our survival and our well-being. The human body has more microbial cells than human cells, and although a few types of bacteria and viruses can make us sick, many other types actually defend us and limit the effect of the harmful ones. Bacteria in the human gut help us digest food. Viral DNA in humans helps us process and store memories. From this perspective, each of us is a metropolis teeming with life. And like the residents of the city that contribute to its culture and make it run, the microbes of the human body contribute to its vitality and give it energy and personality. Microbes help make us who we are. As I read this description, you will shed 2.5 million bacteria, breathing them out and shedding them from your skin and hair. Most of them will die. And the ones that survive in our typical architectural environments tend to be the ones that have antibiotic resistance and enhanced virulence, the ones that are most harmful to humans. Yet in environments with high diversity of microbial life, the harmful organisms tend to be outweighed and mitigated by the benign ones. So what if we could change our architectural environments to be better hosts for a diversity of microbes and to decrease the amount of harmful ones? Rooms could have different microclimates and many types of microbes. Equipment for ventilation, heating, and cooling could be supplemented by microbial reservoirs. Materials could be sponges, textured, porous, and organic with infinite surface area. A bioreceptive material like loofah could be designed to catch and host microbes with tiny cavities of different sizes and shapes that create different pockets of shade, temperature, moisture, airflow, and nutrients. With walls as a bioreceptive material, architecture becomes a cloud to nourish humans, and in turn, buildings become stewards for the urban microbiome. And a new kind of living architecture might involve probiotic buildings. A holobiont is a collection of diverse species living symbiotically, each contributing to the well-being of the whole. The humans, microbes, and other organisms in the holobiont are mutually supportive. In this way, we are all made of each other. And this gives us a new way of thinking about multi-species architecture. In the future, buildings with porous surfaces could behave like our skin and gut and support colonies of microbes tuned to create healthy spaces organically and inexpensively. These buildings might look very different than the ones we currently inhabit, opening doors to new ways of thinking about how we live and how our cities are organized. Humans are the microbes of the city. And with microbes, as with humans, diversity is the key to well-being. So I will wrap up with that. Basically, the conclusion is more or less that to design for diversity is to design for living together and to design for our collective future. Thank you.
Wow, that was a fantastic end to this series. Veena and Henry, you can join us back, and we're gonna break into our little panel discussion here. There's so many things to unpack, but I would love to start with the idea of access. I think all the time, new materials, new technologies, new ways of thinking break into a discussion, and we all get very excited, but then these new ideas are not accessed by the people who need it the most. It's usually accessed by the rich or whomever. And there's a lot of different parts to access. It's about locality, but it's also about engagement. And so I'd like to hear from all of you how you think about access to new ideas, be it policy, be it new materials. Veena, would you like to start us off?
Sure, thank you so much. And thank you, Henry and David, for those fabulous presentations. I was furiously taking notes. So really, really cool. Yes, I think from a policy perspective, the community outreach and engagement is so key, and that process piece of really building in the community engagement to policy development as well as policy implementation is critical. So that community input is about how the policies are actually created and the substantive content, and then also in implementation and enforcement and how it's working. And it's kind of a two-way conversation and an iterative process to make sure that policies are going to work for the communities that they're serving, and that once it's implemented, it's working as designed and can be kind of revised and changed as needed.
Henry?
Yeah, I think like she said, outreach is very important, but also I think, you know, with outreach comes education, but also educating the builders, the architects, you know, the real estate agents, you know, everyone that's in that whole community to understand these different types of materials, educate them, and what will be the cost and the process of implementing them. Is it something that, you know, our local building code enforcers would allow? Something that architects have worked with before? And once we get that education and, you know, we get past that, you know, initial step, actually proving the concept, seeing how it performs, you know, on a day-to-day level, and in the long term as well. So I think as more confidence is brought into these different types of materials, the more that the market will begin to demand them and get more into the mainstream.
Yeah, I've been taking a lot of notes as well. Like Veena, I'm still thinking about something you said, Veena, about interconnected systems. So I think probably, you know, to me, you know, thinking about healthy materials invites us to think about interconnected systems. And I think it's not a stretch, and it's a good way of thinking about it, that, you know, when we're thinking about, say, the carbon footprint of materials, we also have to think about labor and livability and biodiversity and social equity, because all of these things are already interconnected. And I think the real insight for me is to design with that in mind. So we need to design these interconnected systems. We need to design not only low carbon materials, but all of these other things that low carbon materials or high carbon materials are connected to. And we need to think about designing that as a system, not just one-off replacements between like regular concrete and low carbon concrete, but redesigning the entire system, including the buildings themselves and all these invisible layers of, you know, labor and equity and microbes and, you know, these things that we can't see, but that are really important. So I think it's a great question. I mean, access, I think, invites us to think about one of these invisible layers that are connected to a lot of other invisible layers. And I think that's you know, the direct immediate challenge is, you know, rapid decarbonization, but it's connected to so many other challenges. And we're probably not even going to solve rapid decarbonization without addressing, you know, these other things, right? So addressing them all together, I think is really necessary. The last thing I'll say is scalability. I think I've increasingly been thinking that, you know, one-offs are not enough, right? So that's why something like this community that's, you know, that's happening right now, and the Carbon Leadership Forum and the AIA and other ways to bring people together, we have to act collectively, in other words, because we're not going to have scalable impact without, you know, just doing individual projects. We need to come together and think about everything we're doing as like, what is the scalable impact of this?
That's a great point. This idea of interconnectivity makes me really wonder, and it makes me want to bring up Kathleen's question about breaking down silos. How do you find a way to bring in those who often don't have their voice heard in these discussions, and how do you bridge the gaps between policy, industry, and designers? Henry, you want to start with that?
Yeah, give me the tough one. Yeah, I think I think bringing that in is, let me think about that. If you skip me, I need to think about that for a second.
David, why don't you talk about, you have so many, you know, you're a designer, but everything we just saw from you guys is not what people would imagine to see at an architecture firm. So maybe you could talk about who you bring to the table.
Yeah, I mean, I think it would be accurate, but probably too easy to say that, like, you know, some amount of like interdisciplinary collaboration is really important. I mean, to me, and I think to breaking down silos. But I think actually beyond that, I mean, innovation in terms of, you know, say hemp materials, in terms of new kinds of policy, I think always invites breaking down silos, because anytime you're like, you can't rely on the way things have been done before, then it opens up ways to, like, you know, you don't have to just ask, you know, one person for the end all be all opinion on one topic and another person for the end all be all opinion on another topic, but you can, you know, you have to get in the same room and, so to speak, and solve things together. So, you know, Henry, I see your work as already breaking down silos to, you know, to get that stuff built, you know, to get those codes approved, you know, and Veena, you know, your work as well. But I think it's a great question, because what all I'm saying is a little bit more like circumstantial, and I wonder if we could be more deliberate, almost create like a handbook for how to break down silos that would be more actionable. You can see I'm in the kind of actionable mindset and scalable mindset. What do you think, Veena?
Yes, I agree with that, and I would say, in my experience, it's sort of happens on many different scales, in the sense of there's silos even within my own organization, you know, like folks that are focused on, you know, their specific piece of policy work on, you know, protections for endangered gray wolves, and other people working on supporting clean energy, and other people working on food waste. So even within my organization, we tend to be in our silos. So just talking to my colleagues, you know, across some of our intersecting work on health and buildings and building materials has been a really important endeavor, because I think doing the work in our own sector is necessary, but then also that sort of cross sector and reaching across sectors. And I think, you know, what you said about bringing people together is so important, that from the policy perspective, we found that creating these spaces for coalitions where folks can't, like, for example, from kind of like affordable housing developers, you know, tenants' rights organizations, housing advocates, energy efficiency advocates, folks that don't necessarily sit at the same tables, can come together and really think about common cause and what are the fundamental things they all want, and how to get there. And there's a lot of power in that sort of unified agenda and common cause.
Okay, gather my thoughts there. Yeah, like you guys said, you know, for me, I think ultimately it comes down to keeping the end user, the inhabitants' best interests in mind, and one, you know, especially their health. Breaking down where are these materials coming from, reducing and eliminating the toxicity. At the same token, you know, what is our impact on the environment? And when you guys are talking about all these silos, at least for me in my personal experience, you know, never have I seen a building material that really tried to incorporate, you know, a farmer, you know, with industrial hemp. And, you know, I moved here from Miami to Austin about 15 years ago, and I really didn't even know what farm to table was in terms of the organic food industry, and, you know, meeting your local farmer and, you know, understanding, you know, how did they grow the food, or how did they treat the animals, or whatever that might be. And, you know, hemp kind of brought an aspect of kind of farm to home for me to understand, hey, you know, the materials that I'm purchasing here locally are helping support rural farming economies, you know, that have been decimated over the years with huge agriculture. So to help, you know, uplift those communities, doing something more sustainable, and then really, you know, getting everyone, like you mentioned, Veena, to the table and understanding, hey, what is your part in helping give the best outcome to the end users and the inhabitants of these built environments. And I think if we have kind of those goals, you know, in mind, you know, one thing that builders and developers will always be driven by is profits. But if we're able to maybe reduce that a little bit, or able to bring these alternative materials to a scale where they're still, you know, profitable, but you're still doing a lot more good to the environment, or even from a policy perspective, you know, if it's something that could be incentivized with tax breaks or whatever that is, to incentivize the developers and builders to use these materials, I think it could be a win-win all around, and really break down those silos and have it more of a communal process.
Great answer. Way to pull the thoughts together. I love it. I want to continue on the idea of intersectional, and I want to pull towards locality. Veena, I was really surprised to see that all of the spray foam facilities were in like the same area, and there was a great question that came from that. Would love to hear what folks think about the intersectional issues related to the fact that areas where toxic facilities are located are facing enormous risks due to natural climate disasters like hurricane/flooding, but are also in states that are least likely to support sustainability, climate change, decarb policies, etc. How do we address this? Veena, you can start.
Yes, thank you for that observation and that comment. Whoever asked that question in the chat. You know, I'll say I was not surprised to see all the those manufacturing facilities in the same place on the Gulf Coast, because that's where a lot of fossil fuel and petrochemical infrastructure is concentrated. So that is unfortunately, I'd say a pattern, a common pattern, to see kind of multiple industrial facilities concentrated in one place and generating a lot of kind of additive and cumulative impacts to those communities, and that, as the commenter pointed out, are going to be exacerbated by climate change. So I think, from my perspective, it's sort of a multifold response and strategy that we need, in that we need protections in the near term from these climate disasters, like when there's hurricanes and releases and explosions at these facilities. We need the facilities to have strong risk management plans in place, transparency about what is at these facilities, so communities and first responders can know that information. So that there's kind of the near term, we need better protections for communities in proximity, and better plans for the inevitable increase, unfortunately, in these climate related disasters, to be prepared for them. And in the longer term, we really need a transformation of our systems. In this case, our systems that are creating a lot of our building materials away from these hazardous feedstocks, so that they are not so prone and susceptible to serious disasters when there are events that affect facilities.
David, do you want to continue the thread there?
I have a couple of thoughts, but I guess I'm a little bit going back to thinking that it will be helpful for us to, in general, to think about designing, you know, back to the system thing, designing open systems rather than like fixed solutions. So how does that relate to locality? Because, you know, an open system could adapt in different ways to different places. So I know I was kind of reading into some of what you were describing, Henry, when you were talking about, you know, all the different, you know, ways that you have to take, you know, the local materials. And it was similar to working with mycelium materials. That's one of the, you know, potential benefits, is that you can use, you know, rice husks for, you know, if you're making a mycelium material in a certain part of the world that has a lot of rice, you can use corn stover in another part of the world. And so designing these kind of open systems, these things that you can almost like, not to overuse this metaphor, but like license them out, you know, to different use, as opposed to like one central facility that's like making all of this like singular solution and exporting it to all the world. So I also think that kind of thinking, it's good for dealing with some issues of locality. It's also good for dealing with uncertainty, because I think we have to acknowledge that like we know a lot now and we should start acting immediately, but things are going to continue to evolve and change. And if we're designing these open systems that are a little adaptive and responsive, then as things change, we're not too locked into one way of doing things.
Yeah, I like to add that, you know, with those facilities, unfortunately, I live in the state that mostly has all of them in Texas. But, you know, if we can find, you know, I think of your work, David, or maybe if it's something with hemp or another natural material that can give the same effect that spray foam does, and really start to, you know, to find those alternatives for those, you know, encapsulated, you know, every cell closed structures, and bring that alternative, then that reduces the demand. And then, you know, crazy part of me is thinking, hey, how can we do some Wall Street bet squeeze with this type of material where the market, you know, just doesn't want to use it anymore? Education campaigns coupled with a similar non-toxic alternative spray application that we can use, because I think that's really the only way. You know, a lot of these builders, developers that I've experienced, you know, they just go with it because they've used it before, it's worked. You know, they really don't have, you know, the end user's health in mind. So I think the educational campaign comes in that regard. But if you're able to bring an alternative with the same performance and application, you know, just so they feel, you know, it doesn't take a lot of, you know, contract or training to transition them to that material, then we check off a lot of those boxes, and then hopefully reduce the demand so much that, you know, those facilities can't operate anymore.
There was a great question from James Kitchen, who spoke in our, I think, episode 2, structural. He's over at Mass Design. He's asked, do you think there is an opportunity to intertwine these non-toxic material manufacturer facilities into the normal urban realm, like urban farming? Henry or David, maybe one of you can talk to that.
I would say in short, yes, but Henry, you go ahead.
Yeah, I think so too. From a more, you know, micro-sized manufacturing facility, if that's what that James is asking. I think for scalability, you definitely need to be outside of the urban or even the suburban areas if you're looking to do at scale. But I think it's definitely possible. And, you know, hopefully when you get to these regionalized areas, you know, depending on what phase of the processing supply chain you're at, maybe there are, you know, some urban facilities and aspects that can help either finalize those materials or, you know, help in that supply chain process.
Yeah, just to pick up on that kind of smaller scale decentralized thing, I think it's actually really interesting. One of our collaborators for that mycelium brick project is this I guess they're not quite a startup anymore, but I still call them a startup called Ecovative that does a lot with mycelium materials. And they early on created this kit called a GIY kit, you know, in the spirit of DIY, like do it yourself, but this was grow it yourself. Because this is relevant because with this kind of material, anyone could do it, you know, and you don't need a lot of large equipment, and you don't even need that much of controlled, you know, conditions. It can grow in room temperature. It can grow in the dark. If it's a little bit light, that's okay. If it's humid, that's probably fine. You know, you can use, you know, just like things to, you know, kind of keep it kind of moist. So I think there's something interesting about the possibility that a different type of healthy material might be able to be more decentralized and might be able to be more like made by people in their own home or neighborhood and not rely necessarily on global supply chains. Not to say that for some things we don't need to think globally, of course we do, you know, and we need scale. And we could, I think that's a great question because just like urban farming, there's some really exciting aspects about having it right there and the participation that Veena and Henry were talking about, like that's so important, but we have to think scale too. So like, is there enough rooftop to make all the food we need to eat in the city? Is there enough, you know, rooftop to make all the hemp we need for our, you know, for our neighboring building in that vacant lot? So we do have to think at scale. And I think, so I agree with Henry on that point as well, that both looking at the micro, but thinking, hey, we're going to need a huge amount of like cubic meters of stuff, of like concrete like stuff. So where are we going to grow all the hemp? And like, how many acres do we need? We have to do that kind of thinking as well.
Veena, do you have anything you'd like to add?
I think they covered it really well.
Yeah. Okay, we have about 5 minutes left. Keep your questions coming. I do want to start to bring it all together now. Could all of you kind of reflect on each other's presentations? Maybe Veena, you can start.
Sure. Well, I really appreciated the variety of perspectives that we each brought to this. That in some ways didn't seem to be kind of coming from very different angles, but I do think there's a lot of connections between them. And you know, David, I really appreciated what you said in terms of transforming our systems and designing open systems that can be sort of tailored and modified to localities and regions, because I feel like that's very consistent with you know, what the environmental justice and just transition movements, you know, are kind of saying on the ground in terms of what we need local and regional systems and economies that work for us and sustain our communities and bring kind of wealth and value to our communities. So I really like that concept of system transformation that that can work with the sort of principles and agenda that we're hearing from communities on the ground.
Henry?
Yeah, you know, both of these perspectives are so complementary, like Veena said, you know, especially the work that she's doing on the advocacy, the consumer education. I think the more educated we get, I think all the building materials need an ingredients list like we have on our food, even more importantly than food actually sometimes. And if we can really work on that advocacy level and educate people on the alternatives that we have and why we're using them, I think the market will demand it like they did with the organics and the non-GMOs. You know, with the amazing work that David's doing, you know, got, you know, me really excited. I think, you know, with an industrial hemp and mycelium, there's so many opportunities that are literally at the tips of our fingers to be able to be implemented on a large scale. And if we can really find a way to infiltrate, the building industries, to implement them at a scalable level, even if it's starting at a small percentage, 5–10%, that'll be such a huge impact in our built environment. And the way, population is growing, construction is not going to slow down anytime soon. So if we can find ways to implement those things, especially how amazing mycelium works or how fast industrial hemp grows, and really prove the non-toxicity and sustainability of this, plus finding incentives, either that be tax breaks or at a legislative level to educate and complement those things. Both of these presentations really got me excited about that, to work cohesively to make these things happen.
David?
Yeah, I would just add that I think first of all, just to go back to thanking you, Brian, and the whole organization for putting on a series like this. It's so important and great to see everyone here. And not to make too neat of any conclusion, because all of these things are kind of evolving and open-ended and complex. But one way that I was just thinking about is, well, we heard a little bit today about, what could maybe be categorized as like, we know what to do and we just need to do it. So like the policy, we just, we need the policy to scale it up and to have rapid action. And so we need to be like all hands on deck for the policy and get it done. And then materials, we have like immediate materials, these amazing hemp materials that are transformative, and equally important, more important almost, they're ready now. Like we can use this stuff, we know how to do it, it's tested, it scales. And at the same time, I think, so we know what to do and we just need to do it now. And at the same time, we should keep exploring and pushing for new ways to transform both materials, but also new ways of living. And so maybe, we can understand some of my experiments in that realm. Like mycelium bricks are not exactly ready for, prime time scalable outdoor use now. I think they could be soon, but I think we need to keep pushing some kind of experimental ideas at the same time we're like accelerating the things we know already to do.
Thank you. This has been a fantastic end to the series. It's been a fantastic series. Thank you to the 3 speakers for joining us. Thank you to the audience for tuning in every single time. As a reminder, all of these recordings will be on our website at the CLF SF Bay Area. And if you didn't have a chance, we will make sure that there's a link to our contact sheet if you want to join working groups after. The goal of this series was first to bring all of this information here and talk about and expand our definition of healthy materials. And the next step is, like David was saying, time to do it. Okay, thank you all for joining. Have a great time for the rest of your day or evening or night or morning.
Thank you, Brian.
Bye.